You have a terrible habit of showing up uninvited. But since you're already standing there staring at me, you might as well make yourself useful. Hand me that beaker. I was just thinking about a certain fool who believed his upperclassman was disappearing from the world, simply because people stopped looking at her. It sounds like adolescent nonsense, a psychological delusion. But the terrifying truth is, quantum mechanics suggests the universe actually works exactly like that. Sit down. Do not interrupt me. Today, we are going to talk about the most infamous anomaly in modern science, the Double Slit Experiment. And by the time we finish this coffee, you will question whether the chair you are sitting on is actually there when you close your eyes. To understand the absurdity of the quantum world, we must first look at the logical one. Imagine a wall with two vertical slits cut into it. Behind that wall is a screen. Now imagine I give you a bucket of marbles and tell you to throw them randomly at the wall. The marbles that happen to go through the slits will hit the back screen. You will see two distinct vertical bands of hits on the screen. Simple, logical. Particles act like particles. Now, let's change the ammunition. Instead of marbles, we send a wave of water toward the two slits. The wave passes through both slits at the same time, splitting into two separate waves. As these new waves ripple outward, they crash into each other. Where the peaks meet, they amplify. Where a peak meets a trough, they cancel each other out. When this messy, overlapping water hits the back screen, it doesn't leave two bands. It leaves an interference pattern, a series of many alternating bright and dark stripes. Remember this rule. Particles create two bands. Waves create an interference pattern. Any middle schooler can understand this. Let's drop the marbles in the water. Let's use the building blocks of reality electrons. Tiny, solid particles of matter. We fire electrons at the double slit. One by one. Let me emphasize that. One single particle at a time. There is nothing for it to crash into. It is completely alone. You would expect it to act like a marble, right? It must go through the left slit or the right slit and eventually create two bands on the screen, but it doesn't. When we fire electrons one by one over time, they hit the screen and build an interference pattern, a wave pattern. Do you understand the implication of this? A single, solitary electron leaves the gun as a particle, but somehow goes through both slits at the same time, interferes with itself, and hits the screen like a wave. It is not in one place. It exists as a wave of probability. It is everywhere and nowhere all at once. Naturally, physicists hated this. It makes no logical sense. So, they decided to cheat. They placed a tiny detector right next to the slits to watch the electrons. They wanted to spy on the universe. They wanted to know exactly which slit the individual electron was actually passing through. They set up the detector. They fire the electron. The detector records it going through one specific slit. Ah, caught you, the physicists thought. But then they looked at the back screen. The moment the detector was turned on, the moment the electron was observed, it stopped acting like a wave of probabilities. It collapsed back into a single, predictable marble. It created two simple bands on the screen. When you are not looking, matter is a wave of infinite potential. The universe exists in a state of suspended animation, but the second you look, the second you measure it, the universe is forced to make a choice. It collapses into a single, fixed reality. In physics, we call this the collapse of the wave function via observation. But think about what that means for you. If reality physically changes its behavior based on whether or not it is being watched, then what is the universe when all eyes are closed? Does the moon exist when no one is looking at it? Albert Einstein hated that idea. But the math doesn't lie. Perhaps that fool Sakuda wasn't entirely crazy, if people stop acknowledging your existence. If they stop observing you, maybe your wave function just disperses. You fade back into a wave of mere probability. My coffee is cold, and you've wasted enough of my time. If your brain hasn't completely melted, try to perceive the subscribe button. By observing it, you might just force it to change its state. Now get out of my lab.